Oh boy, we saved the best ones for last. Now they get fun. Okay, so if I'm trying to make this piece function differentiable everywhere, the first thing is it has to be continuous. So if it's going to be continuous, when I look at that, I raise an eyebrow when x is 2 because I say, ooh, I get a nice cubic function when x is less than 2 or equal to, and I get a quadratic function when it's greater than. Both of those are continuous. So, scratching head. So the only place I think I need to be worried is what's happening when x equals 2. Well, I have to make sure that they both generate the same value so that I don't have to pick up my pencil. So when x is 2, for the first one, I'll have AA. And for the second one, I'll have 4 plus b. And they have to be the same, equal to the same amount. So that's why I set them equal to each other. And then I go, good grief, now I have an equation with two different variables. What am I to do? So the second piece is, not only does it have to be continuous, but their derivatives have to be the same from both sides. In other words, from the left and from the right side of 2. So I'm going to look at the derivatives first, figure out what they are. So the derivative for the first one, well, let's see, I would power down, cause me to do 3 times a, because a is a constant, so I'd have 3a, and then lower the exponent, and that's when x is less than or equal to 2. And then I look at the second one. Now remember, b is just a constant, so I have to power down. So that's going to give me 2x plus 0, because the derivative of a constant is 0, and that's when x is greater than 2. So again, I need to make sure that the derivative is the same for the upper piece and the lower piece when x is 2. So if x is 2, for the top piece, I'm going to have 12a, and for the bottom piece, I'm going to have 4. Oh my goodness, I can solve that. If I divide by 12, I'll get a equals 1/3. And then, once I have a, I learned this in Algebra 1, I can plug it back in, and so I'll get 8/3 equals 4 plus b, and if I subtract 4, aka 12/3, I'll get b equals -4/3. And now I have my two answers, which will make it continuous and differentiable. I would suggest maybe on another piece of paper, you do that problem again by yourself, just so that you go through the motions and the thought process of what do I do? What do I do? So pause the video long enough to read the directions for the first one before I start. So this is really just using all of my rules. If I want to take the derivative of h of x, and I go, oh, well, this is just a constant coefficient, so that's the constant multiple rule, and then I would just take the derivative of that. Subtraction just means I get to take the pieces separately. Again, I got another constant multiple, and then I would take the derivative of that. So I've rewritten it down here. So h prime of x would equal what I just said. So now if I want h prime of 3, just like when I do f of 3, you go, oh yeah, plug in the 3, Torres. Good job. So I would just plug in 3 everywhere there's an x. And then I go back and I read my directions and I go, hey, wait a second. I have this. It's -2. Good, 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 good. And hey, I have this. It's -6. Good, 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 good. So I'm going to get -4 plus 18, which is 14, Torres. Yay!